This is the second video for the RF Essentials review for SRT2. So RF will go through walls. You already know this. It'll go through non-metal walls, and it will attenuate when it goes through people. It will attenuate when it goes through walls, but it will travel through walls. The one exception here is really about metal. When RF energy, electromagnetic energy hits metal, it bounces off. And so, smaller the smaller the surface of metal, the higher the frequency that this of RF that will affect. Higher frequencies have smaller wavelengths, and large pieces of metal will obviously reflect both small high frequencies as well as large low frequencies. The issue here is that when you have reflected RF energy, you have a transmitter here. This little belt back here is transmitting to this receiver. Direct antenna path here is going to hit this antenna, but you're also going to get a reflection off this piece of metal here, and that reflection is going to arrive late because its path length is, longer. And the problem is that late energy, of course, is out of phase. And when you add the in phase and the out of phase components together, you get some phase cancellation. And that can lead to outright dropouts, right? Essentially, it's creating a comb filter. And so outright dropouts are no bueno at the receiver. Obviously, you don't want things to drop out. There's a lot to be said about this in RF, but the main thing here and what solution we use in our UHF wireless gear is a solution called diversity. Diversity is when you have two antennas on your receiver. You can see this non-diversity system here, and there are some non-diversity audio systems still out there. Specifically, they're usually longer wavelength frequencies where multibath is not less of an issue, or they're cheap gear. But you definitely want diversity in the UHF band. It's absolutely essential. And the idea is that once you space these antennas out and typically angle them like shown here, they are less likely, statistically unlikely, to both see a dropout at the same time from intermod. So, and these receivers use different techniques to do this. There's a technique called true diversity, and true diversity is what you actually want in your receiver. True diversity has some sort of circuits, and there's multiple ways that this is done, but some sort of circuit that continuously analyzes the strength from the two antennas and picks the one of the better quality. So you definitely want diversity. Key to making diversity function is getting those antennas spaced apart. Quarter wavelength of antenna separation is the minimum. And for most of the wireless gear, we use that's actually not very much. That's 6 inches or something. But if you get your antennas 1 to 2 feet apart, you're going to be good for both low frequency VHF and high frequency UHF. So some people space their antennas much farther apart, and that's okay too. There's nothing wrong with that, but 1 to 2 feet is about all you need. And the other thing is you should probably angle them like this. Angle them because a wireless transmission is polarized. It does have an angle that from it leaves the transmitter. When you change the angle like this means that no matter where that transmitter is held in angle, it will still somewhat be picked up by one of the two antennas. Rolling into the best practice here, this last couple slides here, it's separate your antennas by at least a couple feet, and you're good. And here's a little bit more specifics. UHF 3 to 6 inches, VHF, which is a lot lower than what we normally use. Our gear is right around 500 megahertz, so 3 to 6 inches is fine for separation. But lower frequency gear, 2 feet. That's why I say 1 to 2 feet kind of covers all wireless gear. Angle your antennas so you can maximize your diversity, and keep your antennas away from metal surfaces. There are some very tiny antennas that do require them to be close to metal surfaces to get a ground plane, but most of the gear we use at school, that's not the situation, and you need to move those antennas far away from metal because you don't want a really obvious comb filter situation being created. Last slide here, is kind of a rule of tens, and these rule of tens are pretty vague here, but put your antennas at least 10 feet in the air. That ensures that your antennas are more likely to actually see the transmitters, see the microphones, see the IEMs. So gets people out of the way so people won't absorb energy. And then keep your microphones, keep your antennas 10 feet away from your microphones, your transmitters, and away from your receivers. 10 feet away is a nice safe rule. And lastly, keep your microphones at least 10 feet away from each other, which is not always doable, but you do your best to try to keep RF gear away from each other. Okay, so there you go. Happy dappy. Enjoy your homework. See you soon.